Okay, here's an example where I know a side, and then an angle. And I mentioned earlier that these side-side angle ones, some people will read it the other direction. I mentioned earlier that these ones sometimes cause some problems. So if you have one of these triangles, just be careful as you're going through them. So again, it's the ones that include side-side and an angle that you don't know in that order. So a side, an adjacent side, and an adjacent angle. So let's take a look. We can't do anything with the angles on the inside, so I'm going to go to my sine law, and I've got sine 30 degrees over 8 is the same as sine b over 10 is the same as sine c over c. So a lot like the last one, I don't have too much information about c yet, so I'm going to solve just using the a and b ratios. So sine 30 degrees over 8 is the same as sine b over 10, and I just multiply both by 10 and get a decimal place for whatever 10 sine 30 degrees is equal to. So that's about 0.625. I think it works out quite nicely. And then I calculate b by doing inverse sine of 0.625, and I get an answer of about 38.7 degrees. But I just want to stop here and think for a second. How many times between 0 and 180 do I actually have solutions? According to ASTC, there should be a couple of different solutions for when sine b is equal to a positive number. There should be an answer in quadrant 1, and then there should be a second answer over in quadrant 2. And I have found the first answer, and I could certainly use that, but maybe there's another triangle that exists. In fact, to me, angle B here doesn't look like it's 38.7. It kind of looks like it's actually bigger than 90. So maybe there is another solution that I could have here, and of course there is. This number here is really your reference angle, and so 180 take away 38.7 would be your other solution, and in this case that would be 141.3 degrees. And what that's really saying is our picture is a little bit wrong, and that other triangle actually a little bit more accurately looks like this. This is still 10 and this is still 8, but I don't know this side. This is that changing missing side over here, and so now I get a triangle where that's 10, this was 10, that's 8, this is 8, but this is much smaller, it's 38.7 degrees. And both of those are 8, 10 to 30, 8, 10 to 30. However, they're quite different looking triangles. And so here's the problem with these SSA triangles, is because there are two solutions here, I actually have to do the work for option number 1, and I have to do all the work for option number 2. So for option number 1, I need to find this missing angle. That's not too bad. I just add the triangles on the inside, and that would give me angle C. Add the angles on the inside and make sure they're 180. That would give me angle C is 8.7 degrees. And then I can use the the sine law that I have here to calculate the missing side C by using sine 30 degrees over 8 and sine 8.7 degrees over C, cross multiplying, and getting C times sine 30 is 8 times sine 8.7, dividing both by sine 30, and dividing this other side by sine 30 degrees, and getting a C value equal to 8 times sine 8.7 degrees over sine 30 degrees, which is 2.4. So this side here would be 2.4. That would be my C value, and this would be 8.7 degrees in here. And across from the smallest angle is the smallest side, the next smallest angle, the next smallest side, and the largest angle, the largest side. But that's only option number 1. Option number 2 requires me to do the same work, and I'll do it in green since I haven't used that, and use 38.7 degrees as my angle. So then C will be different. In fact, it'll be 180, take away 30, take away 38.7, and this one will be the largest angle, actually down here of 111.3. And so now I'm going to do this exact same work. It'll be sine 30 degrees over 8, but now my C will be 111.3 over C, and I'll be solving for this missing C up here in green by cross multiplying. C sine 30 is equal to 8 sine 111.3 degrees, and divide both sides by sine 30, and calculate what the C value is. And in this case, I get a C value of 14.9. So this side here would be 14.9, and then the largest side would give the largest angle, the largest angle and largest side are associated. The next is associated and the last ones are associated. So I actually have two different options. This triangle here, which I have now solved, I have all three angles and all three sides, and this triangle here, where I also have solved everything with all three sides and all three angles, and I have to do both sets of work. So I produce both solutions and both answers for full marks because there are two different triangles that satisfy those initial conditions. This is known as the ambiguous case of the sine law. It's ambiguous because I don't know which triangle I'm supposed to solve for, so I have to solve for both triangles. Okay, we'll get some practice in class. See you then.